Hypothesis is an assumption or a claim. When you assume or claim something without any valid proof backing it up, that's what you call hypothesis. For example, one day you wake up and you put yourself on a weighing balance. You see that your weight has increased or you have grown fatter. Now, your weight being increased or you growing fatter is a fact. And from this fact, you assume that if I exercise for 30 minutes every day, then I will lose weight. Now, this right here is an assumption or a claim made by you. So, this right here is a hypothesis. Now, whether or not this hypothesis is right or wrong, we don't know. In order to test whether your hypothesis is right or wrong, you carry out a trial. Basically, you start exercising every day for 30 minutes. Now, there are two possible outcomes. One, two. After exercising every day for few days for 30 minutes, you either lose weight or you don't lose weight. If you lose weight, this means that your hypothesis is confirmed, your hypothesis was spot on, right? It was right. But if you don't lose weight, that means your hypothesis was wrong. Again, so what did I say? There was a fact that you had grown fatter. In order to lose weight, you assumed that you had to exercise every day for 30 minutes. But you still don't know whether or not exercising every day for 30 minutes will lead to losing weight or not. So in order to test your hypothesis, you start exercising every day for 30 minutes. If your weight decreases, that means the hypothesis was right. If your weight does not decrease, that means your hypothesis was wrong. There are two types of hypothesis. Let's denote hypothesis with H. So there are two types of hypothesis. There's your null hypothesis, which is denoted with H naught, and there's your alternative hypothesis, which is denoted with HA. During hypothesis testing or during carrying out trials in order to test your hypothesis, you test null hypothesis. But before that, what exactly is a null hypothesis and an alternative hypothesis? Let's look at it with the help of an example. Let's say we have a great scientist right here, and his name is Apex. What Apex does is that Apex discovers two variety of drugs, a blue pill and a red pill. Now, Apex tries out both the blue pill and the red pill on a certain patient. So on x-axis I have the pill, on y-axis I have time. 0, 2 hours, 4 hours. Upon trying out his pills, he finds out that blue pill shows its effect within 2 hours in the patient and red pill shows its effect within 4 hours in the patient with a difference in action of 2 hours. From this, Apex comes with the hypothesis that blue pill is faster than red pill. But then whether or not this is true or not, Apex doesn't know. So he has to carry out few trials in order to test his hypothesis. So he tests null hypothesis. For that, you need to know what exactly is null hypothesis. So first we have null hypothesis, which is denoted by H naught. The word null means nothing, or you could also say no difference. While writing null hypothesis, you have to make sure that a difference is not shown between the two variables, or basically between two variables, a difference is not established. For example, in this case, between blue pill and red pill, you are not supposed to show a difference while writing the hypothesis. So hypothesis would look something like this. So null hypothesis is blue pill is not faster than a red pill. So this is your null hypothesis. Second is alternative hypothesis. As the name says, alternative hypothesis is an alternate to null hypothesis. If in null hypothesis you don't show any difference or a difference is not mentioned, in alternative hypothesis, difference is mentioned. So if you were to write an alternative hypothesis for the null hypothesis right here, it would be blue pill. Wait, blue pill. Blue pill is faster than red pill. Now, what Apex does is that he takes the null hypothesis and carries out trials. He carries out trials for hypothesis testing. Now, after carrying out trials, he either rejects or accepts the null hypothesis depending on the result of the trial. If the result of the trial is in favor of the null hypothesis, then he accepts the null hypothesis. If the result of the trials is against null hypothesis, then he rejects the null hypothesis. In other words, if null hypothesis is rejected, that means alternative hypothesis is accepted. That is, when Apex rejects null hypothesis, that is, he rejects the hypothesis that blue pill is not faster than red pill, then automatically his hypothesis blue pill is faster than red pill gets accepted. While carrying out hypothesis testing, various types of errors can be seen. So in this particular part, we are going to look at how during hypothesis testing, we get various types of error. So first things first, hypothesis testing is carried on null hypothesis. So we have an alternative hypothesis here which says blue pill is faster than red pill or creates a difference between two variables. And then we also have a null hypothesis here which says blue pill is not faster than red pill. So basically it does not include any difference. So what Apex does is that Apex takes this null hypothesis and carries out tests in this null hypothesis to check for its validity. This is how it's done. So what do we have? We have our null hypothesis. Now null hypothesis in reality, null hypothesis may be true or false. We don't know whether null hypothesis or Apex doesn't know whether null hypothesis is true or false. But then it is either true, null hypothesis is true, or null hypothesis is false. In order to check for the validity, Apex tries out various trials, and based on the results of those trials, he either rejects the null hypothesis or accepts the null hypothesis. If we compare the reality with the result of the trial, four different scenarios come out in front of us. Let's look at each of these scenario one by one. First scenario is where H naught is true. That is, null hypothesis is true. That is, it is true that in reality, it is true that blue pill is not faster than red pill. But as per his trial, Apex trial, he rejects this hypothesis. So what is happening here? Here, Apex is rejecting something that is true. That is, it is a truth that blue pill is not faster than red pill. But Apex rejects this hypothesis and says that no, blue pill is faster than red pill. So obviously there's an error. And this type of error is what we call type 1 error. So what is type 1 error? Type 1 error is such an error which is seen during hypothesis testing where the null hypothesis is true, but then based on trial results, the null hypothesis gets rejected. Okay, second case. In second case, the null hypothesis is false. That is, in reality, blue pill is not faster than red pill is a false statement. In reality, blue pill is faster than red pill. But then based on trial result, this hypothesis gets rejected. So in this scenario, something that is false is getting rejected. That is, apex rejects such a hypothesis which is actually false. So is there an error? Obviously not. Error would occur when something true would get rejected or something false would get accepted. In this case, right thing is happening. That is, blue pill is not faster than red pill, and based on trial result as well, blue pill is not faster than red pill is a hypothesis which is being rejected. So again, in a reality, blue pill is not faster than red pill is a false statement. In reality, blue pill is faster than red pill. And based on trial result as well, blue pill is not faster than red pill is getting rejected, and blue pill is faster than red pill is getting accepted. So here there is no error. Third case. H naught is true. That is, it is true that blue pill is not faster than red pill, and it is getting accepted as well. So something that is true is getting accepted. So obviously there's no error. So basically, in a reality, blue pill is not faster than red pill, and based on trial result as well, blue pill is not faster than red pill is getting accepted. Fourth scenario. H naught is false. That is, blue pill is not faster than red pill is a false statement. Blue pill is actually faster than red pill. But then this false statement is getting accepted. That is, based on trial result, the false hypothesis is getting accepted. So obviously there's an error. And since here the null hypothesis is false and the false null hypothesis is getting accepted, it's a type 2 error. So one last time, what is type 1 error? Type 1 error is such an error which occurs in hypothesis testing where the null hypothesis is true, but then it is getting rejected. Type 2 error is such an error in hypothesis testing where the null hypothesis is false, but then it is getting accepted. Out of the two errors, that is type 1 error and type 2 error, type 1 error, type 1 error is more dangerous. It is more serious. So while carrying out hypothesis testing, Apex needs to make sure that there is as less error as possible. And he especially needs to make sure that there is as less type 1 error as possible, because type 1 error is more serious. Okay, now there are three different values that you need to know. Number one is p-value. Number two is beta value. And number three is alpha value. What are they? Okay, p-value is nothing but the probability of doing type 1 error. So what's the probability that Apex performs type 1 error while testing his hypothesis? That's p-value. Beta value is probability of doing type 2 error. What's the probability that Apex performs type 2 error while carrying out his hypothesis testing? Now, among the two types of error, type 1 is more serious. So, what Apex needs to do is that make sure that beta value and p value both comes out to be less. But then if he can't manage beta value, he needs to make sure that at least p value comes out to be as less as possible. Okay, since getting type 1 error is more serious, a threshold has been kept for type 1 error, and this threshold or maximum acceptance of type 1 error is what we call alpha value. Alpha value is the maximum type 1 error that is accepted. And internationally, the maximum type 1 error that is accepted is 5% or 0.05. So, during hypothesis testing, there's a probability that the p-value may be equal to alpha or equal to threshold, p-value may be greater than threshold, or p-value may be less than threshold. All these possibilities are possible. But then in order to get significant result, again I'm repeating, in order to get significant result or best result, you need to make sure, or Apex needs to make sure, that p value is less than alpha.